This is the beginning of section 9.2, and I think we spent 3 days. Tomorrow we'll do radians, and then on Friday we're going to do something called arc length and area of a sector, which you also talked about in geometry, but we're going to look at it one way. Geometry, you might have looked at it two ways. Before we get too far into discussions from 9.2, we all have to agree to a particular type of angle in algebra, and that's going to be an angle in standard position. This is a little bit different than what you think of when you think of angles in geometry. You know, angles were just sort of like shapes out in space, this way, that way, which way, right? And we're going to fix our angles to the coordinate plane in algebra and calculus and beyond. Okay. So an angle in standard position has a vertex at the origin, an initial side on the positive x-axis. So I have in blue, this is an angle in standard position. I'll move it up so you can see it. And I'll label. So every time in this class when you draw an angle for me, the initial side is always the positive x-axis. Okay, so always going to the right. The other side that opens the angle is called the terminal side. Terminal just means end. Okay, so that's the side that can open up in any of the four quadrants. Okay. So I'm going to label that the terminal side. Now, another important piece to an angle in the algebraic perspective is the direction in which it opens. So what I have pictured on the screen, you see that little red arc in the middle? That's really important. When I ask you to like sketch angles, you should show me the arc of the direction and how many revolutions you made. So sometimes you'll see spirals when you're sketching angles. And if it's going, we would call this counterclockwise, because if our initial side is at the positive x-axis, when our angle opens in this direction, we're going against the clock. So we're kind of like reversing time, right? That's actually a positive angle. I'll have that on my next slide. Okay. But so this is an angle in standard position that is positive. It seems a little bit weird at first that counterclockwise is positive, but when you think about it as opening up so that your terminal side goes up, then that starts to feel better. Okay, so let's talk about this positive and negative angles business. Positive angles open counterclockwise, negative angles open clockwise. And if you want to draw an image for yourself, these two angles that I have on the screen, I mean, the blue parts look exactly the same. And we're going to talk about that a little bit later on in the slides. They're really the same angle if you look at terminal and initial side. But the arc that shows what direction my angle opens says these two angles have different measures. Now we could probably look at these two angles and attempt to estimate the value of the angle. So if I were looking at this positive, just to kind of give you an idea of like when I'm figuring angle measure, when I'm trying to sketch an angle measure, here at the positive x-axis, that's like 0 degrees. Okay. And then when we go counterclockwise, so we go up to the vertical y-axis, that's 90, 180, 270, and we're back to 360. So 1 revolution is 360, which we would all probably agree with. So we might estimate this one to be 120. Okay, great. Now, if you have a negative angle, the only thing that changes is you're moving clockwise. So you still start at 0 over here. But when you go clockwise, instead of being 90, it's negative 90. Then it's negative 180. Negative 270 is at the positive y-axis. And we're back to negative 360. Have you seen that before in geometry? I'm not sure. Tell me, what do you think? Never seen a negative angle before. Oh, okay, yeah. So that's kind of like a weird difference geometrically to algebraically. Is we're going to allow angles to be negative, but that just means they open clockwise. We have like some things that in trig and algebra later on, we also allow sides of triangles to be negative. Well, because it's on the coordinate plane, it just represents a direction for us. And that's the same for this negative angle. It's about the direction of the angle, not necessarily the size of the angle. Okay, so what would you estimate the one on the right to be? Like maybe negative
240.
240. Okay, would be great. Okay, good. Okay, so this is our first example. Some things that you'll be asked to do on your homework include drawing an angle, so like sketch an angle. I'll show you what I would like to see for your angle sketch. And then it will also ask you which quadrant your terminal side is in. That's going to be important later on in our chapter. Okay, so let's look at negative 120. Okay, if I was asked to sketch negative 120, I'm going to start at 0 degrees. Because it's negative, I'm going to go, negative is clockwise, right? Okay. And I'm just going to, I usually just go by the 90 degrees and then just keep adding until I feel like I know where it's at. So negative 90, negative 180, and I don't have to keep going because negative 120 is in between those two, right? So what I want to see on your homework is you show the initial side at the positive x-axis. You place your terminal side where you think negative 120 is. In between negative 90, negative 180, closer to negative 90. You show the direction of your angle. Okay, so that we can all see that that's negative. And now you can answer. In which quadrant is that? Quadrant 3. So you can use regular 3 or you can use Roman numeral 3. I'm just going to go ahead up here. Remember, it goes 1 is the positive quadrant, and then it goes counterclockwise. 2, bless you. 3 and 4. Okay. Okay. Now, the next one is 400 degrees. Well, that's an interesting one, right? Probably in geometry, maybe you didn't even experience any angles that were more. Did you ever have angles that were more than 180? I'm trying to think if you do that when you do circles at all. No? No. Okay. So you maybe said straight angle was as good as it gets, like a straight line, and then it's, then it becomes just a regular angle again. Okay. We're going to say that we kind of have angles that, because we're just talking about going around this origin, like if we put a pin there, we're just going around and around. So this is more than a full rotation. So if I'm graphing something like 400, I'm going to be thinking like this. Well, obviously we start at 0. This is positive, so I'm going around counterclockwise. And I'm really, for 400, I'm not going to take the time to label 90, 180, 270 because I know this is 360, right? So I'm just going to start at 360. If I take 360 and I add 90, I get 450. Do I now know where angle 400 is?
Correct.
Yep. somewhere in between 360 and 450. So I put my initial side on the positive x-axis. I never have to think about that. It's always right there. And 400, something like that. Now here's the fun part. When you have multiple or one rotation or multiple rotations, you get your whole spiral. Cool. Okay. So start at your initial side. We're opening counterclockwise. So we're going through 90, 180, 270, 360, and a little bit more. If you have something like 1,000 degrees, okay, that's 360, 720, and then some. It's not 3 rotations, so that's 1080. Now, which quadrant is 400 degrees in?
1.
Okay, now notice, if I were to take away my red arcs that show me like the direction and the rotation for my angle, and I just gave you this angle in blue with the first one, negative 120, but I didn't show you the arc. Some people might look at it like an angle negative 120, but other people might look at that angle and say it's 90, 180, oh, maybe it's like 240. And this one, if I take away this red spiral and all you saw was the blue, you might estimate that second angle to be like 40, 45 degrees. Okay. So this brings up this idea that you can have angles that look exactly alike, but they have different measures.
That's like 360.
Well, yeah, if I took away my arc and took away my labels, yeah. I guess if I'm just looking at the little angle that's blue, you might measure it differently. And if I didn't even have that, some people might say that's negative 320. Like I'm going negative almost a full rotation. So there's lots of different ways to label that. That's called coterminal. So jot this down. Does coterminal angle sound the same to, or sound familiar to you? I need to talk to the geometry teacher and figure out. Did you ever talk about coterminal? From the middle school? You didn't have Miss Kelly last year at Liberty. Okay, coterminal angles are angles that share a terminal side. So essentially, they're the same angle because they're the same initial, same terminal. They look exactly the same, but they have different measures. And that's because I'm just like doing different rotations, right? Or I'm going negative angle. So I just drew like 3 images here, and you could draw whatever you want for your red arc, but I'm just trying to display here. These 3 now look all the same, right? And probably if we just went out in the hallway during passing period and asked a random person, look at this angle and tell me its measure, probably most people would answer something like 120, right? But we could also say maybe we go around 1 time, so that's 360. Maybe we go around another time, so that's 720. And then we do like plus 90, what is that? 810, 900. I'm going to say like 970. Make something up. Or maybe somebody looks at it in this way. And so they're thinking negative 90, negative 180. Maybe this is like negative 240. But regardless of what their measure is, they're really the same angle. Okay, so I think it's on this slide. Let me see if I can get this thing to go away. Oh, I'm so close. Aren't I close?
Yeah.
Oh, there, I got it. Thank you. Okay, so mathematically, how can we find coterminal angles? We add or subtract 360. I mean, think about that. If you're a terminal side out there in quadrant 2, how can you be a different angle and get back to exactly the same spot? Do a full rotation. And you could do that full rotation counterclockwise or clockwise. And it just brings you back to that same spot, right? Well, let's say there was somebody who was like making some really bad life choices. Okay, they're going down the wrong path. And then something changes and they make a lot of good. Have you ever heard that phrase like they made a 180? Okay, 180 would be on the opposite side, right? It would be only like here I am. If I go 180, I'm like somewhere totally different. Okay, on the opposite side. So if I'm making bad life choices, down the wrong path, and I do a 180, I've turned good, right? I'm making better choices. I'm doing things right. Making good on whatever I need to do. Sometimes people misspeak. Listen for this sometimes. Sometimes people say, oh, you made a 360. Well, I hope you were good in the first place. Because if you do a 360, you're right back where you started, right? So it's just kind of an interesting thing in the English language. But you should say people, when you want to say they're in a totally different place, they did a 180. Okay, they turned it around. A 90 is like a little change, but not quite fully committed to your change. Okay, so here are some examples of what your homework might ask you to do. Find one positive and one negative angle that are coterminal with the given angle. Okay, so we want it to be the same angle. If we graphed them, they would be in the same exact location, but we want them to be different measures. And so we want to be in the same exact place. We want to do a full 360. If we're at negative 100, how can we get a positive coterminal angle?
Add 260 or
Add 360. Get 260. So negative 100 plus a full revolution takes me right back to where I started. That's 260 degrees. And if I was the angle negative 100, how could I get a negative coterminal angle? Just subtract 360. Do a negative rotation. I'm just going now clockwise. Minus 360, so negative 460. So I got one positive and one negative. No. Unless the directions say sketch. Mine don't. Yeah.
It feels like negative 2,000. And then you couldn't add 360 to get a positive.
Oh, okay. So what if, like, that's going to be like my 575 right here. Okay. So your question is, what if your angle was negative 2,000? If you add 360, you're just at what? Negative 1640? Right?
Yeah.
Okay. But that's like wherever negative 2,000 is, right? Help me out. Is this clockwise for you guys?
Yes.
Okay. Then you're at
No,
no.
sorry.
Okay.
No.
Yes.
I wasn't.
I can't do it backwards.
I just,
Okay.
I don't
So
know.
let's say this was negative 2,000. I don't know where negative 2,000 is. And you went around clockwise. So you add. No, I want to go counterclockwise. I'm adding 360. Is this counterclockwise?
Yes.
Okay, so now I'm at like negative 1640. What would you do?
Keep adding.
Keep adding 360. So, while I have two answers up there, 260 and negative 460, those are not the only coterminal angles. We could say there are infinitely many coterminal angles with negative 100. You could keep adding 360 10 times and then give me an angle. My guess is most of my students are like me and want to do the least amount of work possible, so they'll only add 360 once, and if it's positive, they'll call it good. Want to make extra work for me? You can add 360 10 times. Be nice. Now, 575 is going to be a good example. What would you do to get a positive coterminal angle? Okay, you could do one or the other, right? On this one, I heard Elise first. She said subtract 360. If I subtract 360 from 575, isn't that still going to be positive? Yeah. So what does that give me? 215? 215? Okay. If you were thinking in your head that you would take 575 and add 360 because you want it to be positive, would that have also worked? Sure. That's going to be 935. Okay? Either one is fine. You only have to give me one of them. Okay? And I'll accept both those answers. To get the negative coterminal angle, this goes back to Aiden's question. If you only subtract 360, do you get your negative coterminal angle? No. So then you have to subtract 360 again. So you're really doing 575 minus 360. Nope, that's still positive. Minus 360. Yeah, negative 1.5.
Boom.
Questions, concerns?
Why is it 215 or?
Well, so Elise was the first person I heard. I said, how would you get a positive coterminal angle? And she said she would subtract 360 because she recognizes if 575 is more than 360, I'll still get a positive answer when I subtract, right? Now, Mason, if you want to add 360 and get a big angle, that's still positive. So either one works. Okay. Your homework assignment then is not going to take you very long. Okay, it's these problems here on page 474, and you got that pink sheet from me, the extra practice. Okay. And we really went over that in our notes. I think I filled in a table and I told you to write down the page number. So if you need some help with those special angles, you can look that up in the book. That will come from section 9.1. Tomorrow we're going to introduce that radian. That's going to be probably the part of section 9.2 that really gets people because it's just like a new way to measure angles and it includes the value pi. So just be prepared for that tomorrow.